All right, I have an awesome neuroscience demo for you guys today. I am going to be using my brain, my central nervous system, to control someone else's peripheral nervous system. And we're going to be doing that through electrical communication. So far we've been talking about neurons, and I have a motor neuron here specifically because that is the neuron that's going to allow me to have my central nervous system communicate with my peripheral nervous system as well as someone else's. So let's recall the structure. We've got our dendrites over here. This is where I'm going to receive the signal. It's going to travel down our axon, and recall that we have myelin sheath that insulates the neuron, that's going to control the speed of the nerve signal. The Schwann cells are what produce the myelin sheath. And then we have our nodes of Ranvier, which is where action potential occurs, which we have not yet discussed. That's what we're going to be getting into. Then we talked about how the signal will go down to the axon terminal, and through neurotransmitters, it's going to transmit to the next neuron. And we've been discussing how different drugs are going to affect the different neurotransmitters. So we are going to be taking advantage of the fact that we have a nerve that runs along our arm about here, like on the pinky side. It's called the ulnar nerve. And it's close enough to the surface of the skin that I can connect electrodes to it, and I can actually transmit that electrical signal to someone else's arm. So I'm looking forward to it.
Ooh.
Okay, and then I want to point out that if my brain is not the one sending the signal, because we need that electrical signal for me to control his arm, if I physically move my arm like this, oh.
I got a little bit of a jolt. I
moved my finger.
Yeah. Nope. There we go.
But if it's not my brain doing it, if I'm physically moving my arm, then we're not going to have that same effect. All right. Let me just stop recording now. Perfect.
Oh, guys, this feels really weird.